Good morning, viewers. Today we are going to discuss set theory, which is the base of modern algebra, and we will discuss these three parts of set theory today. What are the definition of set, representation of set, types of sets? First, what is definition of set? A collection of objects is said to be a set if it is well defined and contains distinct objects. You see three terms here: collection, well defined, and distinct. Okay. Now question is there, what is collection? All of you know this word collection of stones, collection of fish, like that. And here collection means actually collection of some objects from many, or collection of all also. Now take an example to clear this. See, collection, suppose you are students of class 10 and there are 40 students in your class. I tell you, collect those students from your class having whose height is more than 5 feet. So clearly and easily all of you can collect the names of those students having height more than 5 feet. Okay. Now next is similarly many collections there, set see collection of natural numbers, collection of whole numbers, and collection of class 10 books, like that. Now another word is there, well defined. What is well defined? See, actually well defined, by this word it should be possible to decide without any doubt whether the objects belongs to the given collection or not. What I say, I'm writing this. Well defined. Well defined. By this word, it should be possible to decide. It should be possible to decide without any doubt whether the objects belongs to the given collection or not. Means what? See, if I say you to collect the tall students from your class, then what's happened? I tell to all the students, collect the tall students from your class. Then different students will write down the different names. Why? See, talls here, height of the tall students are not given. So what's happened? Any students can think that the students having height more than 5.2 feet is tall. Another student will think no, he's not tall. He will think that the students having height more than 5.4 feet is tall students. Okay, so a doubt or controversy arises here. Okay, so this collection is not well defined. So what I say, this collection of tall students, collection of tall students. So this is not a well defined collection. But if I say a collection of tall students having height more than 5 feet, then this is a well defined collection, isn't it? So this one is not well defined, not well defined. But the previous one, that is collection of tall students from your class having height more than 5 feet, it is well defined collection. Okay, so this one is well defined. Okay, now some more examples of well defined and not well defined collections. Okay, suppose I'm writing on examples, collection of beautiful flowers. So clearly see, this is also a what type of collection? Not well defined collection. Okay, so this is not well defined. Okay, another one, collection of good or bad students. This also is a not well defined collection. This is also a not well defined collection. Defined collection. So from these two collections, it is clear that on the collection which indicates quality of the objects are not well defined collection, that is these are not set. What I say? So star marks. So the collection which indicate quality of objects are not well defined, that is not a set, okay. So now take some examples of set. What are these? Okay. Collection of natural numbers. All of you know collection of natural number means natural number started from 1 and it 1 2 3 4 5 6 and so on, okay. And generally natural number set denoted by capital N, and the members of the collection written within curly bracket. And what are the members of natural number? 1 2 3 4 and dot dot, okay. Now another example, collection of rivers in India. It is also a well defined collection because it is clear to all which names you have to list inside this collection, okay. So this is a well defined collection and this is also a set and this is also a set, okay. Another term was there, distinct, no, okay. But actually distinct mean in the definition there was one term, distinct, okay. Actually when you write down the names or members or the objects inside the collection, we write down the defined objects. Means what? Suppose I have written a collection A B C D, so no members are repeated here or no objects are repeated here, so this is a well defined collection as well as all the elements are different, so this is a set, okay. But if I write down A B again A D, right? Here I have written the same elements, the same objects repeatedly, so this is not a set. So keep it in mind when you write down the elements or members or objects inside the collection, it must be different, okay, must be different. So hope you understand the set. Many some examples are there, some more examples are there, I'm telling you. Suppose all rivers in the world, this is also a well defined collection of whole numbers, collection of prime numbers, all these are set, okay. Next we are going to discuss representation of set. This is representation of a set. Representation of set. See, generally we represent the set in two forms. One is roster or tabular form, Okay, and second one is property or set builder form. Property or set builder form. Builder form. First, roster or tabular form. First, roster or tabular form. Okay, see, in this form we represent all the elements of the set within the curly bracket. What I say? Suppose I am writing, first I am writing a set, which set of whole numbers, whole numbers. Okay. Set of whole numbers are denoting by capital W. Okay, and here I am telling one more things. We must write down all the sets by a capital letter. That is, we denote the sets by a capital letter of English alphabet. Okay, here set of whole numbers, we are representing set of whole numbers by capital W, and we'll write down the members inside the curly bracket. What are the members? Set of whole numbers started from 0, then 1, 2, 3, 4, and so on. Okay, so this is the representation of a set. What is the set? Set of whole numbers. We have represented the set of whole numbers in roster form or tabular form. It is clear to all of you? Next, set builder form. Set builder form. Set builder form of property form. Say set builder forms. In this form also, I am writing the same set in the set builder form. That is set of whole numbers in the set builder form. Here also we have to represent the members of the set within curly bracket. Okay. First, we write down a variable, say x. Then we'll put down the colon, which is called as such that. And next we'll write down the property. What is the property? Here x is a whole number. Whole number. Okay, understood? W equals to x such that x is a whole number. It is in the set builder form. We'll write down the members also inside the curly bracket. First, we'll write down a variable, that is x or y, like that. And here x indicates all the members of this set. All the members of this set. And we can say the element also. That is, members of the set are called element. Sometimes we call the elements. These are elements 0, 1, 2, 3, 4. Okay. Elements means what? Element means member of the set. Okay. And see, we can write down the same set like that also. What? I'm writing the set a, capital letter A, then x, such that. Here a standard notation are used. W generally we used to represent set of whole numbers. So we can write down x such that. What is the property of x? X belongs to W. Okay, x belongs to W. This is the property. This set can be, that is set of whole numbers, can be represented in set builder form in that way also. Okay, hope you understand how to represent. Now taking one example. Represent the set of square numbers. Represent the set of square of natural numbers. Natural numbers lies lie in between 2 and 30. What I say? Represent the set of square of natural numbers lie between 2 and 30 in tabular and set builder form. Okay, so what is the set here? Set of square of natural numbers lie in between 2 and 30. You have to represent in tabular form as well as set builder form. Okay, so first we are writing this set. This is the set. Okay, this is the set of square of natural numbers lie in between 2 and 30. We are representing this set in tabular form at first. Tabular form. Okay, we are representing this set by capital letter B. Okay, now in the tabular form all the elements must be written within curly bracket and members or elements of the set will be written inside this curly bracket. What are the members? Set of square of natural numbers. Same. Natural numbers started from 1, then 2, 3, 4 and so on. There it's square. That means 1 square. What is the square of first natural number? 1 square. 1 square equals to what? 1. But it is less than 2. So we will take this. Next natural number 2. Its square means 4. Isn't it? So we will consider this. That is 4. Then next natural number 3. Its square is 3 square 9. Next 4 square means 16. Then 5 square means 25. Then 6 square means 36. It is exceeding 30. So we will take this. Okay, see, first 1 square it is less than 2. We will not take this. 2 square 4 is greater than 2, so and also less than 30, so this will be considered as the member of B. And also next 3 square means 9 is lie in between 2 and 30. 16 also lie in between 2 and 30, and 25 also lie in between 2 and 30. Next 6 square 36, it is exceeding 30, so we will not take this. So this set can be represented in tabular form in this way. Okay, now set builder form. Okay, set builder form. Same set will represent set builder form. I told you at first we write down a variable x which represent the elements of this set. Next, property of the elements. Okay, what are the property? X lies in the set of natural number, that is x belongs to capital N. Capital N means what? The set of natural number. Okay, next semicolon. One more property is there. See, x belongs to N as well as x is square of natural number. Now we represent this set in the set builder form. We represent this set by capital B and curly bracket start, and its member are written by x. Okay, then x equals to r square and r belongs to capital N, and then also one thing is there, x must be lie in between 2 and 30, that is 2 less than x less than 30. Okay, now see, so first I told you in set builder form, first we write down in variable x or y, then property. See, clearly here it is given we have to consider those natural numbers square those natural number square which lie in between 2 and 30. Okay, so and see from here what are the natural numbers? Here r are the natural numbers. Okay, and here x is the square of the r, isn't it? So here x is the square of r and r is the natural number. So clearly if we take r sum 1, then x equals to 1 square, but it does not belongs to this because it is exceeding, it is less than 2. Next take r equals to 2, then x equals to 2 square, that is 4. Okay, then take r equals to 3, then x equals to what? 3 square, that is 9, which lie in between 2 and 30. So this must be member of B, like that. Okay, next, types of set. What types of set? Types of set. Types of set. Types of set. First, empty set. Empty set. Empty set means what? The set contains no element. The set contains no element is called an empty set. Empty set, and it is denoted by phi. What is this? Phi or curly bracket. There is no element inside the curly bracket, so it denote empty set by phi or curly bracket. Okay, one example. Take an example. Collection of whole numbers. Collection of whole numbers less than 0. See, whole number started from 0 and there is no whole number less than 0, so it is empty set, there is no member. Similarly, you can say collection of natural numbers less than 1. This is also empty set. Okay, next, B, singleton set. Singleton set. Singleton means it contains only one element. Set contains the set that contains only one element. One element is called singleton set. Singleton set. As for example, suppose S equals to 1. This contains only one element. This is singleton set. One more example. Suppose P equals to x square equals to 4, and x belongs to n. See, x square equals to 4 means x equals to plus minus 2, but minus 2 does not belongs to n. Okay, so this contains only one element. Clear? 2. So this is singleton set. Next, C, finite set. Finite set. Finite set means the set that contains limited number of elements. The set that contains limited number of element is called a finite set. Example, see, empty set is also a finite set. Okay, and see, singleton set, this is also a finite set. Next, some more example. So set of prime numbers less than 20. We represent this by p. Then set of prime numbers less than 20. We are writing this set in the tabular form. What are these? 2, 3, 5, 7, 11, 13, 17, and 19. Okay, this set contains limited number of elements, so this is a finite set. Next, infinite set. Infinite set. Infinite set means what? The set that contains unlimited number of elements. Okay, unlimited number of elements is called a infinite set. Okay, the set that contains unlimited number of elements, this is called infinite set. Example, set of whole numbers, set of natural numbers, all are infinite set. Okay, set of whole numbers, it starts from 0, 1, 2, 3, 4, 5, and so on. It is no end, so it contains unlimited number of elements, so this is infinite set. Similar set of natural numbers, 1, 2, 3, 4, 5. This similarly, I'm writing one more set in set builder form, which is infinite set. Suppose p, I say x such that x belongs to R and 2 less than x less than 3. What is this? R? R means set of real numbers. R means set of real numbers. Hope you know, real numbers between any two numbers are infinite. Okay, that is between 2 and 3 there are infinite number of real numbers. Between 2 and 3 there are infinite number of real numbers. Okay, so unlimited number of real numbers in between 2 and 3. So this is infinite set. Okay, this is also infinite set.